So when you graph 3 sine x plus 4x on your class pad, you will get this bad boy over here. Right? So that doesn't look like anything fancy, it just looks like a trig graph that's been shifted horizontally. So let's take y equals 3 sine x plus 4 cos x. Okay. Now I'm going to factor out a number, and this number is going to be the magnitude of these two coefficients here. So the magnitude of 3 and 4 is 5. So I'm going to factor out 5 from my equation.
That's a big range of problem.
Yeah, I know. But when I factor out 5, I have to divide this by 5 and divide this term by 5. So what I end up with is 3 over 5 sine x plus 4 over 5 cos x. Have I changed my equation at all? No, I've just factored out a number so that this should equal that. So let's point out to you that 3 over 5 is a fraction, or is a ratio, and 4 over 5 is also a fractional ratio that can be written differently. So 3 over 5 can be written as sine alpha, where alpha is an angle, right? And then we have your sine x plus 4 over 5 cosine alpha and cosine x. Why have I done that? Well, I'll explain quite simply. This is because I can use my cosine rule. So my cosine rule says that if I have cosine A take B, that expands into cos A cos B plus sine A sine B. So far this makes sense. Can I use this rule here to turn this into a cosine? Do you see the relationship with cos A cos B and cos alpha cos x? Yeah. So this guy is the same as that, and that guy is the same as that. So I can transform my function into cosine A take B. So it's, which one is it? Is it alpha take x, or is it x take alpha? In this case it doesn't matter because you can multiply them both, so you can move them around. I would use x take alpha. Alright, put the double brackets in there. I don't need to write in these big brackets, so I can go 5 cosine x take alpha. Now the reason why I can move those around is because those are multiplied. Right, so it doesn't matter which way I move them around. Now what is alpha? Well, I know that sine alpha is 3 over 5 and cosine alpha is 4 over 5. What's alpha? Let's draw a little triangle so you can see what it looks like properly, right? So you have your angle there, you have alpha, you have 4, you have 3, and you have 5. So to find alpha, I can take either one of these and do the inverse sine or the inverse cos on the calculator. let me just show you right now. Make sure it's in degrees. So I can go inverse sine. Inverse sine brackets 3 over 5. 36.9. Let's round it to one decimal place. So alpha is 36.9 degrees. One decimal place. So now my y can be written as 5 cosine x take 0.9. And that's why this function here does indeed look like a cosine graph that's been shifted to the right by 36.9 degrees. Any questions? That sort of makes sense? Alright. I'm going to give you some time now to do these two questions. I'll just pause it. Alright, so this is the same as that one there. For this one here, sine x take alpha, that should look like, using our sine rule, yes, so that should, if we have a sine, so on up here, if we have sine A take B, that is sine A cos B, take or plus? Let's take cos A sine B. Alright, so the sine A cos B, cos A sine B. See how it's different? So we're going to have to turn this left hand side into something that looks like that. So once again, let's factor out the 5. So we have 3 over 5 sine x plus 4 over 5 cos x. Okay. So we know that 3 over 5 has to be cos alpha or sine alpha? Cos or sine. So let's call x A. So if x is A, we need a cos B. So that would be cos alpha. I'll write the full thing down so you can see it. And that one over there is going to be a sine alpha. Cos x. So what I'll do is I'll flip these around so it looks like that one there. So I'll flip these around. So I have sine x cos alpha plus cos x sine alpha. See how this now looks like that? With me? Alright, so now I can go ahead and change change this into sine x take alpha. Ooh. It does have a plus. Sorry, pretty sure that's a typo. If you just put a plus right there, that would be good. Sorry about that. Alright, so to find alpha, it's cosine minus 1, 3 over 5. Which is the same as 53.1 degrees. So we can write that final step. Come in. You have a maybe I'll come up later. Okay. Alright. So, now we can write this full thing as 5 sine x plus 53.1 degrees. And there we go. Make sense so far? Alright. Flip it around. Boom. We've already done that. So we don't need that one. Did we just do it? Yeah, we just did it. Alright. Oh, we did 3 sine, 4 cos. So now we're going to do 3 cos, 4 sine. Do we need to write everything out, or can we just sort of figure out what graph it's going to form?
The same one as on the previous page.
Yeah, so I mean, just for, I know that that's going to be 5, 3 over 5, and then cosine. This time it's theta plus 4 over 5 sine theta. So what should these two become? It really depends on whether I want it to be a cosine, or a sine. So I can write that as a cosine. And that will change to cosine alpha take, sorry, theta take alpha, where alpha is 53.1. Yep. Just 5 cosine theta take 53.1. Boom. Alright, try that one by yourself. I'll give you guys a few minutes. Alright, so I'm gonna find my A first. A is 2 squared plus 3 squared, 13. So now I have root of 13. So you can do the same thing. Factor out root 13. Turn that into cosine alpha. Turn that into sine alpha. I'm going to flip it around just to make it easier for myself. So that can be turned into a, probably don't need that bracket, so it's cosine theta plus alpha. Alpha is the, let's use that one. Cosine inverse to root 13. Use my calculator. 2 over root 13. 6.3. Is that what you got, Macklin? So that one's quite simple as well. If you want to skip these steps because it's quite tedious to write it all down, once you know what the form is, you can sort of figure out what alpha is. So we know r is going to be 5 squared plus 12 squared, or root of that. That's going to be 13. Yep. And then alpha will just be, let's see, cosine, next one, 5 over 13. So I'll skip all these steps here, but once you get the hang of it, you should know whether to use sine or cosine. And that'll give you 67.4, which means we've got 13 sine theta plus 67.4. Alright, let's have a look at this question here. Hence, determine the value of the maximum. Hence, determine the value, the maximum. Let's determine the value of. Hence, determine the maximum value. We'll cancel that out there. Maximum value of 5 sine theta plus 12 cosine theta. The smallest positive value for theta for which it occurs. Ooh. So maximum value. When does sine theta plus 67.4 has this? What can the maximum value of that be? 1. That's the maximum value. And what does this guy have to be? The angle inside there. Smallest possible value has to be 90. So therefore, theta equals 90. Take 67.4, which would give me 22.6 degrees. Now, of course, theta can be more than that, but we want the smallest possible value of theta. Alright, let's do that one there. That one's a little bit tricky, but I feel like we can do it. So by inspection, which trig function should that simplify into? A cosine or a sine, and is it plus or minus? Have a think about it. I'll come back to you. So we said it was going to be in the form of cos A plus B. With an R there, right? So 2 and 3, that's 13. So we have 13 cosine theta plus alpha, and alpha is 2 over cosine, yep. Yep. 56.3. How'd you get that? Ah, yes. It's that one. It's that one there. Cosine 2, I'll just write it out anyway. Cosine 2 over 13. So therefore our final function is 13 cosine theta plus 56.3, and that equals 2.5. How do I solve that? Ooh, well, we got this guy over here. So let's move that over to the other side. cosine theta plus 56.3 equals, well, I don't like this decimal, I'm just going to go 5 and then 2 root 13. No, but I can solve it. What should x plus 56.3 be? So I'm going to go inverse cosine 5 over 2 root 13. Oops, I might have done a mathematical error. 5 over 2, oh yep, let me put some extra brackets around there. 5. There we go. Alright, 46.1. So looking at a diagram here, the 46.1 is there. Where is the other 46.1? Cast? That's the other one there. 46.1. Alright, cast, yeah, CA. So that, well, that angle there is not 46.1, it's actually that. So it's 46.1 or 313.9, and the next one will be 406.1, and it keeps going. Right? So those are all the solutions. So we keep going, and we go back around, and then back around, and back around, it keeps going. We're trying to solve for x though, not x plus 56.3. X has to be in between, well not x, sorry, oh, that's not x, that's theta. Theta has to be in between 0 and 360. So even though that's in between 0 and 360, that's not theta. I would have to take 56.3 away from that one, which would give me negative 10.2. Now if I take that away, it will be 257.6. And if I take that away, it will be 349.8. And if I go any more, it'll be past 360. So my two solutions are that and that. So theta equals 257.6 and 349.8. Ta-da!